In this lesson, we're going to be taking our understanding of scientific notation and applying it to the idea of ordering it from least to greatest. So let's take a look at this first example here. I want to order these three numbers that are in scientific notation, and I want to order them from least to greatest. It's always really important to read the directions before you begin, because sometimes the question might ask you to order them from greatest to least. But let's go ahead and order these least to greatest this time. So here are my three numbers that I have to work with. Now there's a couple things we want to focus on before we actually do this. And I will say that one way to do this is just to convert all three of these numbers into standard form. And by doing that, it will be very easy to order these. But let's go ahead and do that first, and then I'm going to show you some tricks that you can use. So this first number here, 4.5 times 10 to the fifth. So what that is, I'm going to rewrite it as 4.5, and I'm going to move my decimal 1, 2, 3, 4, 5 spaces to the right because I have a positive exponent. I'm going to go ahead and fill these in with zeros. And that's going to be, I'm going to go ahead and rewrite this, 450,000. I'm going to go ahead and work on the second one now, 3.9 times 10 to the eighth. So I'm going to go ahead and write 3.9, and I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8 spaces. I'm going to fill this in with zeros, and then I'm going to rewrite it in standard form. 390 million. All right, and then my last one, 5.2 times 10 to the fifth. I'm going to move it 1, 2, 3, 4, 5. Giving me 520,000. Okay, so by doing this, we can easily go ahead and grab these least to greatest, and I'm going to go ahead and grab my 4.5 times 10 to the fifth because that's the smallest number. Then I'm going to go ahead and grab my 5.2 times 10 to the fifth. And then I'm going to grab my last one, 3.9 times 10 to the eighth. Okay, now that is one way to do this. That method does require a lot of work, as you can see. So I'm going to show you some different things that you could do to figure this problem out. All right, the first thing I want to look at are my exponents. Look at my exponents. I have a 5, I have an 8, and I have a 5. You can see that all three of these numbers are positive numbers, which means that I can actually use these exponents to order my numbers. Now, I have a 5 and a 5, which are identical. So when you have two numbers that have identical exponents, that's when you need to go and refer to your base number. So now I need to look at 4.5, and on the other one, I need to look at the 5.2. Whichever one is the smallest is going to be the least, as you can see indicated here up at the top. So my least is going to be this first one, and then my third one. And then you can see the 8. Well, 8 is the highest exponent. And therefore, no matter what, this is going to be bigger than the other two numbers, making that my third number or my greatest number. So sometimes you just need to look at the exponents to figure this out. All right, let's go ahead and look at another example that's a little bit more challenging. I still have the same question being asked. It says arrange the three terms from least to greatest. So let's go ahead and just do that little tool that I just showed you. Let's just go ahead and look at the exponents. I have -5, I have -2, and I have -2. So if you think about this, think about the exponents and how many spaces I'm going to be moving. So we can see that the number with the -5 as your exponent is going to be your smallest number because I'm going to have to move that decimal 5 spaces to the left, making this much, much smaller than the other two numbers. So I'm going to go ahead and write that in the first blank. 3.5 times 10 to the -5th. Now, between the other two numbers, I really need to think about this because I have my exponents that are identical. This is when I need to go ahead and look at my base number for both of these. Because for both of these numbers, I'm going to be moving it 2 spaces to the left, but I want to know which one is smaller. This is when you have to ask yourself which base is smaller. And you can see that 6.1 is a smaller number than 7.5, meaning that 6.1 times 10 to the negative second is going to be my second smallest number, followed by 7.5 times 10 to the negative 2. Now, that's kind of the trick to do it. You can always refer back to actually solving them all out. And let me go ahead and do that. So this first one, I'm going to rewrite 3.5, and I'm going to go ahead and move it 1, 2, 3, 4, 5 spaces and fill all my placeholders in. So my number is going to be 0.000035. That's going to be my standard form number. The second one is going to be 7.5, and I'm going to move it 1, 2 spaces, giving me 0.075. And my last one is going to be 6.1. I'm going to move it 1, 2 spaces, giving me 0.061. So you can see that these are my standard form numbers. And indeed, they are properly ordered from least to greatest. Now, a common mistake with these types of problems is when we see those negative exponents, we think, oh, the number is negative, and that is not the case. So remember, standard form is just working with that exponent tells you how many spaces you're going to be moving from left to right. Okay, feel free to pause the video at this time and try the next 2 examples on your own. All right, arrange the 3 terms shown from least to greatest. All right, here we go. Let's go ahead and just do that little trick. Let's just look at the exponents. I have a 1, I have a 3, and I have a negative 2. Notice how all 3 of these exponents are different numbers. And I can actually order these numbers using those exponents. So the smallest one of those exponents is going to be the last one here, 2.2 times 10 to the negative 2. The next number in line will be the first one here, 1.2 times 10 to the first. And then followed by the greatest number, which is going to be 8.4 times 10 to the third. Now, all I did to solve that one was use the exponents. But again, I could always write out the number. So I'm going to go ahead and show you what it looks like when you write it in standard form. 1.2, I'm going to move it 1 space to the right, giving me a standard form of 12. 8.4, I'm going to move it 3 spaces to the right, 1, 2, 3, making this a big number, which is 8,400. And then my last number, it's a negative exponent, so I'm going to be moving the other direction this time to make it a small number, 1, 2. So 0.022. So if I were to order these from least to greatest looking at those 3 numbers, again, I would have the order that I have above. All right, I have one more example for you. Again, feel free to pause the video and try this one on your own. This one is probably the hardest of all 4 of them. All right, the first thing I want to do is this. I want to go ahead and look at my exponents. -2, -2, and -2. Well, since all 3 of these exponents are the same, that means that I can't just look at the exponents to order them. I actually have to go ahead and I have to refer to my bases now. Now, when all 3 of the exponents are the same, all I need to do is take those bases and order them from least to greatest. So looking at those 3 bases, I'm going to start with my smallest one, which is 1.4 times 10 squared, or 10 to the -2, followed by 2.5 times 10 to the -2, and followed by 4.9 times 10 to the -2. All right, I am going to go ahead and take a moment and actually write these in standard form so that you can see. The first one is going to be 2.5, and I'm going to move it 1 space, 2 spaces to the left to give me 0.025. The next one is going to be 1.4. I'm going to move it 1 space, 2 space to give me 0.014. And then the last one is going to be 4.9. I'm going to move it 1 space, 2 space to give me 0.049. So again, as you can see, if I were to order these from least to greatest, they're in the proper order above. But for this one, when you have all 3 of those exponents that are identical, all you need to do is look at the bases to figure out the order from least to greatest. All right, that brings us to the end of our lesson on ordering scientific notation.